Hey, good afternoon, everybody. Time is 3 p.m. Let's get started. So my name is Gajendran. I'm a senior engineer working in PayPal. I have 20 years of work experience. All of my experience is on Java platform. And this particular, webinar, we'll be looking into Spring Reactor. See, I am planning to do this particular session for next 1 hour to 1 hour 15 minutes, probably like one and a half hours or less than 1.5 hours. It should get completed by 4:15, 4:20. It will get completed. And the agenda for this particular program, I'm not going to talk more on philosophical side of reactive systems, but we'll write code and then we'll understand the underlying interactions, how you can build applications reactively. Also, we'll talk about something called Spring Web Flux. So that's the web layer on written on top of Project Reactor. So we'll get started. I'll share my screen and then I'll walk through the agenda and then we'll get started. So this is the agenda for next 1 hour to 1 hour 15 minutes. So we'll start with the Reactive Manifesto. For bandwidth reasons, I will take my video off. So this is Gajendran. Right? So I'll take my video off for bandwidth reasons. Yeah. So I hope everybody is able to see my desktop. So this is the agenda for our 1 hour program. We'll start with something called Reactive Manifesto, and then we will enter into Project Reactor. We'll quickly understand what kind of types we have. So we need to understand something like publisher, subscriber, mono, flux, and all those things. And then the architecture of this Project Reactor, how it works, and how we can use this to build asynchronous application from scratch. And then I'm going to go to the Spring Initializer, and then I'm going to create a small Hello World Spring Boot 2 application, which will have the reactive web as a dependency. And then in that particular project, I'm going to write a main class, a simple Java main class to explain about what do you mean by this publisher, what do you mean by subscriber, how the reactive framework works, right? So we need to understand that using a simple main based application. Then I'm going to extend that particular application to use something called schedulers. Schedulers are the way in which you change the threads, which threads wants to execute which part of your underlying pipeline. That can be determined by this particular schedulers. So I'm going to extend the same application by introducing schedulers and then clearly explain you how the reactive pipeline works. Once that is completed, so there are more things in reactive pipeline which we will not be able to cover, like exception handling and a lot of other things are there, and which we will not be able to do. This is just a basic introduction of the reactive application development using Spring Reactor. Once the scheduler part is done, we'll move on to Spring Web Flux. Already I will be creating the project here. Using the same project, we will build a RESTful application which will use the Spring Web Flux programming model. Behind the scenes, a Spring Web Flux is a layer on top of Project Reactor. So we'll get started. This is the agenda for our 1 hour program. First thing, let's get started with the Reactive Manifesto. So in 2014, the reactive part or the way in which this framework is created is not like new thing in the industry. So we need to know some historical background, how all these things came into existence, and then we'll go to Reactive Manifesto. So I have just opened some URLs. I'll get all these URLs as part of our text pad here. Finally, I will copy this text pad information into our chat, into our Zoom chat. So in the year 2000-2001, like 20 years back, there was a challenge in the industry called C10K problem. This is the first origins of non-blocking IO APIs in Java, as well as building something like a reactive frameworks. This is a kind of origin. So what is this challenge is all about and what it is trying to tell? What is the challenge? Somebody in the internet challenged that, can we create a web server which can handle 10,000 concurrent connections, and it should be simultaneously serving 10,000 concurrent connections. So if you see here, this is the one, right? So it can handle 10,000 simultaneous connections, and it should serve responses to 10,000 concurrent connections. So in olden days, the way in which these web servers are designed is not like scalable, right? So it cannot go beyond like say 3,000 or 5,000 concurrent connections because it is designed like that. I will tell you how the Tomcat. So by the time Tomcat was there, like in the year 2001, 2002, Tomcat was there by that point of time. How Tomcat was working at that point of time. So we'll talk about that. And based on this particular challenge, there was a lot of people started building new architectures which uses a non-blocking IO and all those things. And one of the first emergent in this layer is Nginx. So there is a web server called Nginx. Currently, a lot of organizations are using this. So this uses a different kind of architecture, and this using say that kind of say architecture, it is able to serve more than 10,000 concurrent connections. So this is typically a web server written by a team of Russian engineers, and this challenged the C10K say problem. This gave a solution to C10K problem. And then there are a lot of other say people also gave solutions. So this website will give you all the background information, and then what has happened, and then what kind of frameworks, strategies came, IO strategies, and all those things came in based on this particular challenge. We don't want to go very detailed on that, right? So that's the origins of say non-blocking reactive say application development foundation which has been laid. Then at the later point of time, Microsoft created a framework called Reactive X. So this is like in 2007, 2008, and there was a implementation in .NET. And based on the ideas what Microsoft has defined, some of the Java engineers, they created a framework called RxJava. Some of you know about the RxJava 1.x. It's based on Microsoft's reactive extension. You can see that as well. Reactive extensions. This is reactivex.io. And this spec is created by Microsoft, and then there was an implementation in most of the programming languages, particularly in JavaScript, there was an implementation, and in Java also some group of engineers have implemented it, and they name it as RxJava, right? So this provided implementation for ideas which has been say discussed in this particular reactive extension provided by Microsoft. So lot of companies, they want to build a framework for this reactive say kind of environment. So they formed together and they created something like a manifesto, something like a oath they created. So the website here is called reactivemanifesto.org, and in this website they laid out the foundation, like how a reactive framework has to be, right? So I highly recommend to read this particular this one-page website. If you come down, there are like 4 things what they should have been explained here. One is like responsive, the other one is called resilient, the other one is called elastic, and then the 4th one is called message driven. And there is a picture something like this. So a reactive framework should be responsive under high load condition. So if there are like 50,000 concurrent connections comes to your underlying say web server or whatever server-side systems what you are building, your application should be responsive, right? So if a large amount of requests comes also, your application has to be responsive. Resilient, if something goes wrong, the underlying framework should be capable of say be resilient. It should be cloud native. That's what it means. That should be a kind of fault tolerant, and all those things should be built on top of the framework what we are building. And there is something like elastic, and then message driven and all those things. I don't want to go into the details of all these things. This is like a philosophical say understanding how a reactive framework has to be. So please read this and then get to know these terms. So I don't want to go into details of all those things. What do you mean by message driven? What do you mean by this elastic? And then what do you mean by this resilient? And then what do you mean by this responsive? This is a very small explanation which tells, they call it as a reactive manifesto. So any kind of reactive frameworks which is built after this reactive manifesto, this came in the year 2014. If you see here, the date will be there here. September 16, 2014. Any kind of reactive frameworks in open source, will follow this particular reactive manifesto. So it will be responsive, it will be resilient, it will be elastic, and it will be message driven, right? There are a lot of other frameworks came into existence. Some of the frameworks are like Akka. This is one of the framework written by a commercial organization. Actually, the creator of Akka is also a part of this reactive manifesto. Also, Spring, Pivotal is a company who is building a Spring framework. Right? They had something called Project Reactor. That is what we are going to learn now. And then there is other framework like Vertex. There's a lot of frameworks like this, right? But in the industry, if you see currently, the usage of Akka is going to get reduced to a very small percentage. But a lot of organizations started using Project Reactor. So RX Java, Project Reactor, more or less, it will be similar kinds of concepts and similar way how this particular framework has been written. So in this session, we are going to learn about this particular Project Reactor. Let's go into the Project Reactor and understand how Project Reactor framework has been written and what kind of code you will write in order to write your application in an asynchronous way. So before going to that, we need to understand what do you mean by this asynchronous? Why I'm using a term asynchronous, right? What do you mean by this particular asynchronous? What I am trying to tell for this reactive framework. Let's draw a small diagram and then understand how things are going to be. Before that, already written diagram I will show you how a web server will work. Typically, the web servers are going to work like this. Typically, a Tomcat, right? How it is going to work. When an application wants to, when a client is sending a request, here it is given as an application, but in a web application, your browser sends a request. When a browser sends a request, Tomcat has an internal queue. The request will be sitting in that particular queue. And then Tomcat will have a thread pool. This is a pre-created thread which the Tomcat will hold. And this thread configuration, you can do it in Tomcat as well. This we call this as HTTP thread pool. What happens when a task is there in the queue? One of the thread from this particular thread pool will be taken out, and that will be assigned with this particular HTTP request. That's your task. So that request will get executed by one of that particular thread. Once your request is finished execution, the thread will go back to the pool to be reused again. So this is a thread pool concept, and then these threads are getting reused, and each and every request comes to your server, the Tomcat server. It will be queued by a Tomcat queue, and then one by one, the particular request will get assigned to a thread taken from the thread pool. And once your request processing is completed, the thread will go back to this particular HTTP thread pool, and the response will be sent back to your underlying browser. So this is the way how Tomcat works until Tomcat 8. Tomcat 9 also brings a different way of work nature, but until Tomcat 8, it is something like this. So the other picture looks like this. So when a browser sends a connection request, a HTTP connection request, that is going to come and sit in a job queue, and you have a thread pool, and the thread will get assigned to that particular connection, and the request will be HTTP request will be processed. But in the olden days, the processing of HTTP request is very simple. Simply they go to database and then they come back. That's all. But currently, if you see, we have microservices architecture, and then a lot of other things are there as part of your server side, say, processing, right? So nowadays, it is something like this. Imagine this is the time, or this is the kind of processing layer which is going to happen for a single thread. So when a request comes in, so this is a browser request. This is browser, HTTP request, and we make a HTTP request to our server. Say, imagine a Tomcat is there. This is my Tomcat. When a request comes to our underlying Tomcat, one of the threads from the Tomcat will get assigned to this particular request, and that thread lifetime is what is shown here. The big line, what you are seeing, where my cursor is there now, that's going to be my thread lifetime. Means what? The thread is processing the underlying, say, request. So this is the thread processing time. I will name it as request processing time. So this is going to be a request processing time. Now, in a modern architecture in the web layer, in the underlying, say a RESTful layer is called like this, your RESTful service is not going to simply go to database, fix some data, and then send back. It will do a lot of things. What it will do? Let's name certain things now. Say when a request comes in, it does say a small validation, and then it is going to do some kind of logging. Definitely any application you write, you will do logging, right? You will do some kind of logging, right? Some distributed logging or local logging you do. Once that is done, say for example, your underlying request is going to access a database. So let me put a big time for database, and then it is going to do some kind of work, and then it is going to access another RESTful service. Say a typical microservices architecture, one RESTful service will call another RESTful service. We call that as a downstream call. It may call another RESTful service, and then it may say do some kind of distributed logging. So this might be a distributed logging, and then the response will get created, and then the response is going to send back to the browser. This is response. So I will name everything. This is like log. This is like DB call. This is like say another REST call, or we call it as downstream call, and then this is like again distributed logging. Distributed logging, or say local logging, whatever you want to call, you call it. In a typical say microservices architecture, you will do distributed logging. So if you see this line, say the thread, when it's going to do request processing, most of the time it is waiting for something. So when I'm going to do log, actually I'm going to write it to the local hard disk, right? Or to a distributed system, I will write. Any kind of IO call, any kind of network call, the thread will wait until that particular network call, IO call is going to get completed. Similarly, any kind of database call, that's a network call, that's a socket call. So it is going to start the socket call, and it has to wait until your query is going to get executed, and you are going to get back the response here. Similarly, when I want to make another RESTful call, it's also a socket call, because the RESTful service will run in another machine. You need to make a socket call. You need to make a new HTTP request to that particular another RESTful service, and then you need to wait until the response is going to come back. And again, distributed logging also, it's going to be a kind of IO call or socket call. You need to wait for the underlying response to come back. If you see the entire picture here, see only a small section here will be done by your work, will be done by the thread, and this small section the work is being done, and this small section the work being done, and this small section the work being done by the thread. But thread is actually working in your underlying machine. So out of this entire 100%, say 95%, your thread is waiting for say completion of your IO call or a network call. Only 5% of the time the thread is actually doing the work, right? So typically in Tomcat, it will work like this. Any kind of worker dispatcher thread pool model, if your web server is using, then it is going to work like this. This is not okay, right? This kind of thing is not okay. And we don't want our thread to wait for all these distributed call and IO call to be completed. Won't it be nice for us if I am going to make a IO call? I don't want my Tomcat thread to do that particular IO call. Instead of that, let's use some other thread pool to do that IO call. Once that call is completed, it can hand over the data or whatever context to another thread or the same thread to do the DB call. So I don't want my Tomcat thread to do this. Tomcat thread, once it is going to start this particular IO or network call, it just going to go back to the underlying pool, and these background work will be taken care by some other thread in the system, right? Would it be nice if we have some system like this, in which I should be having a facility in which I can hand over my current thread, I can return my current thread back to the thread pool, and I will use some other thread to do these IO and networking call, right? So this is the kind of say environment what we are trying to build now using Project Reactor. So Project Reactor or the reactive systems will give you a kind of environment in which you can easily switch threads. So you can tell function, you get some data into your reactive pipeline. Function number 1, the transformation function, what you want to execute, can run in main thread. The second function, you want to do some network call. You don't want to do it in main thread, but you want to do it in some kind of other thread pool, which is highly optimized for network call. Once that network thing is going to get finished, it has to rejoin. Your network call is completed, then it has to come and rejoin your underlying main thread and then continue. So I want to switch these threads very easily, and then I want to pass data between these threads very easy, right? We want to build a framework for that. That's what the reactive frameworks and reactive pipelines will try to do, right? So now you know the reason why we want to build a asynchronous say framework in the server side. See, from the browser side, it is synchronous only. Browser makes a request and browser has to wait until the response is going to come back. In browser side, you can make use of Ajax and other kind of things in order to say tell that my browser is not waiting, it is waiting in the background thread. In the foreground, my UI may render some other say information. But actually, some background thread in browser will wait for the response to come back, right? So that kind of thing you can separately do it in browser, but in the back and in your underlying server side, instead of your HTTP thread doing all the work, now you will have a facility in which all our network call and IO call can be done by a different kind of thread pool, not by your HTTP thread pool. Because of that, the availability of HTTP threads in the HTTP thread pool will become higher. See, if 95% it is simply waiting, now what I am trying to do, I don't want that thread to wait. I will ask that thread to go back to your underlying Tomcat thread pool. Let this wait can be done by another thread pool, not by Tomcat HTTP thread pool. Right? So the availability of Tomcat HTTP thread pool will become higher if I am going to employ something like this. That naturally increases the scalability of your underlying system, right? So that will naturally increase the scalability of the underlying system. So in a typical hardware, if you have a kind of server running and say it is serving like 5,000 concurrent requests, right? If we are going to serve that particular 5,000 concurrent requests, then if I'm going to have something like this, if your underlying web server is going to support the reactive say framework and all those things, then what happens? It will, your scalability of your underlying server will increase into 5x. So if it is serving like 5,000 concurrent requests, now based on this, it may be able to serve with the same hardware, it may be able to serve 25,000 concurrent requests. So I don't want to create any kind of new say hardware and all those things. Say extra things what I want to tell. So who is writing in the screen? Somebody is writing in the screen. Please don't write in the screen. Somebody is writing in the screen. Yeah. So that's the background of, see, again, somebody is writing in the screen. Please don't write in the screen. Right. So that's the background of say why we want to go with a asynchronous framework in the server side. Now we will go to the Spring Reactor types, how Spring Reactor will help us to do this kind of work in a very, very easier way. Let's see that. I'm going to open a diagram. This I have pre-created it. We don't want to create it here. It will take time to create this, right? So I have pre-created it. So Spring Reactor will provide a programming model, something like this. Let's start with the left-hand side. In the left-hand side, you have a source of data. See, typically a source of data might be a collection or it might be an array. or it might be simple string also, whatever we want, any kind of source of data which I want to process. So this particular source of data will be pulled by somebody called publisher. So there are basically two types here, publisher and subscriber. Subscriber, you see it in the right hand side. In the left hand side, we have publisher. So this source of data will be pulled by the publisher, and there is something called subscriber who will get attached with this particular publisher. So let's go and see this particular publisher type now. So I will go to my IDE, and then I'm going to open the publisher type. Directly I will go to the Maven dependency. I will tell you how I have created this project and all those things after understanding our Reactor. So I'll go to Reactor core, and then I'll go to publisher. Okay, let me open like this. I'll use of Eclipse facility to do it. So this is the first type what we need to learn about. So this is a Reactor publisher type. This is a simple interface, and it's going to have a generic type called T. And if you see this particular publisher is having one method called subscribe, and a subscriber is passed as a parameter to this particular publisher. That's what I have drawn here. A publisher will get attached by a subscriber. When a subscriber is getting attached with the publisher, a pipeline will get created between publisher and subscriber. Whatever data the publisher pulls from the source of data, if it is going to be a collection, say that collection is going to have 100 elements, so publisher will push that 100 elements one by one into this particular pipeline. And once it is there at the end of the pipeline, subscriber will take all those elements one by one from this particular pipeline. So this is what the pipeline programming model, what we are talking about. So publisher type is going to be something like this. It is going to have one method called subscribe. A subscriber will get attached. On a publisher, you can attach n number of subscriber. Each and every subscriber will get their own subscription. Means what? Each and every subscriber will get their own pipeline to connect with the underlying publisher, right? So now we'll go to the subscriber and see. So subscriber, if you see, that's also going to be an interface which is going to have a generic type key. And if you see this particular subscriber, basically there is a non-subscription method which is going to inject the subscription here, and it is going to have three methods here apart from unsubscribe. There is an onNext method which is going to take each and every element in the pipeline and it is going to print it. There is an onError method which is going to take a throwable. Inside the pipeline, if there is some problem, then this onError will get completed. For every element which is passing through the pipeline, onNext will get called, and that every element will be passed on here. Say I told you in your collection, if I'm going to have 100 elements, publisher will get all the 100 elements and it will it will push all the 100 elements in the pipeline, and in the subscriber, the onNext will get called 100 times, right? Once all the onNext method is completed, once your pipeline is trained, there is nothing there in the pipeline, then only onComplete will get called. If there is an error inside the pipeline, then the subscriber will call onError, right? So there are the three methods: onNext, onComplete, onError, right? So your subscriber will have these kind of three methods. So every subscriber has to be attached with the publisher. Then only the pipeline will get created, and the objects, whatever data what we have in the publisher, that will be pushed to this particular pipeline. And in the pipeline, now we will be able to do transformation. So whatever objects, whatever data what we have, if we want to do business logic, then we can do it in this particular pipeline, right? So we can do the business logic in this particular pipeline. That's what we are going to see with the help of an example. And before going to an example, we need to know two more types. One is called mono, another one is called flux. So let's go and see mono first. So mono, if you see, mono is implements core publisher, and core publisher will extend the publisher. So it's a type of publisher now. So there are two types of publisher. One is mono and another one is flux. So mono, what do you mean by mono? Mono will have 0 to 1 element. If you have 0 or 1 element, then you need to represent it as mono. If you have one or more element, then you need to represent it as flux. Say, for example, you have a collection, and that particular collection will be pulled into a publisher. Now you will be using flux as your publisher because the collection will have more than one element, right? Usually you will have more than one element in the collection, then it is going to be flux. If there is a string, there is a single string is there, and you want to take that particular string, parse it, tokenize it based on space and all those things you want to do. That's a business logic you want to do. Then that single string will be taken as mono. Mono is also a publisher, which will take 0 or 1 object, and then the pipeline will get created when you attach a subscriber, and you can write business logic in the pipeline. So in the pipeline, we write the business logic, and based on the business logic, we can tell business logic 1 runs in main thread. Business logic 2 runs in, say, a computation thread. Business logic 3 runs in IO thread. You will be able to switch these threads accordingly. So that's the power of reactive pipeline frameworks, what we are going to have. So as far as, say, basic classes interfaces is concerned, you are going to have an interface called publisher. You are going to have an interface called subscriber. And publisher, there are two kinds of publisher. One is a mono, another one is flux. And if you go and see the methods, what we have in mono and flux, you will have like 200 to 300 methods in this particular mono and flux. Please don't draw in the screen. Somebody is continuously drawing in the screen. Please don't do that. Please don't draw in the screen. Right. So these are all the basic types what we need to know in the reactor. Now let's go and write the code now. I think the explanation is okay now. Let's start writing some simple code, and then we will learn about this mono, flux, and then the subscriber and all those things. So I will go to Spring Initializer. I will open a new window. I'll go to Spring Initializer, and here if you see, this is the kind of Spring Boot initializer where you will be able to create projects. I will change, by default it is 2.2.5, that's the latest version what we have. I will change the artifact to, say, Reactor demo. Remaining things, I'm not going to do anything. And in the dependency, you have a lot of dependency. I will add Spring Boot dev, and then I will add reactive web. There is a Spring web as well as there is Spring reactive web. So we are going to do reactive web. I have added that reactive web, right? So these two dependencies I have added. So here, if you see, these two dependencies come into picture: Spring Boot dev tools and then Spring reactive web. These two dependencies. So I'm going to click generate. This will download the project for me, and quickly I will unzip this to a specific directory, maybe this directory, and I will import this to our Eclipse. So I'm using Spring tool suite. You can use any ID. You can use say IntelliJ or whatever, Visual Studio.code, whatever we want, we will be able to use it. So let's import it as an existing Maven project. So we have done importing, let it import. See, first time when you are going to do, it will download a lot of dependencies, but I have already have all my dependencies in my local Maven project, and it should be okay. Now instantly it got imported. There will not be anything inside this particular project except the main class. The main class, if you see, is going to be like a typical Spring Boot main class. And in the pom.xml, if you see, in the pom.xml, it is going to be a typical Spring Boot version 2.2.5 as a parent. And in the dependency, the Spring Boot WebFlex dependency is there. And then the DevTools dependency is there. DevTools dependency is going to be there. So these two dependencies is what we have added into our underlying pom.xml. Just give me a minute, 1 minute. Yeah. Now I'm good. Yeah, thank you. Thank you. Yeah, so the mute unmute control is not with me. It has been unmuted. Okay, fine. So let's go and import. I think I already imported it. Let's go and see the project. So if we see the dependencies, we have a Spring WebFlex dependency and DevTools dependency. I'll directly go and start my main. So when I'm going to start my main, because this using the Spring Reactive Web, it will not start in Tomcat. It will start in Netty. So Spring Reactive Web will use Netty as the underlying web server. It will not use Tomcat as the underlying web server when you are going to start your underlying main. Of course, you should know basics of Spring Boot and all those things in order to understand how this main is organized and what do you mean by this annotation and all those things. So we'll just go and start creating our first Hello World example in Project Reactor. Let's go and create a main class. So I'll go and create main. My main looks like this. The data what I am going to analyze is this one. Maybe integer. So this is the input data what I'm going to have. And in this, from this particular input data, I'm going to convert it into a flux. So in the diagram, if you see, this part I'm doing now. So I have a source data now, that's an array. And from that array, I'm going to create a publisher now. So I'm going to create a flux from this source data. So flux will have some convenient methods like from array, and then you need to pass your array object. Don't give any type here, and this will return the flux of integer. So this is how you create a publisher from your underlying source. So source can be any collection, it can be any kind of array, it can be a single value. If it's going to be single value, you will be creating a mono. If it's going to be more than one value, you will be creating a flux, right? So you create something like this. Once you create something like this, I'm going to write a business, I'm going to write a business logic now. Now I have done the publisher. I'm going to create a pipeline, and in the pipeline, I'm going to say attach a business logic. So this one is the business logic. What we are going to do, those methods are like the business logic methods, which are, we call it as a transformative methods. There are a lot of methods available in Flux. If you go and see our Flux API, you will know. I will just show you the Flux API, the Reactor Flux API. So these are all the methods what you are seeing. So it starts from here, all, any, as, block first, block last. And if you see here, you will get 200 to 300 methods, maybe more than that. See, still it is coming. See how many methods are there. Lots of methods are there, right? So this is not like going to be easy to understand all these methods, right? Lots of methods are there. And these methods, if you click these method links, hyperlinks, it is going to go give you a detailed understanding or detailed documentation of these methods. And you are seeing a diagram here. This diagram, we call it as a marble diagram. Marble diagram is what you are seeing. For every method here, it will be explained via a marble diagram. Marble diagram, by looking into this particular diagram, some of the things you will be able to understand. So if you look this particular diagram, zip, what it does is like, it is going to zip first each and every element of two publishers. So the first line is first publisher, second line is the second publisher. So it is going to zip A and 1 as one element, and then it's going to zip B and 2 as the second element, C and 3 as the third element, like that it does, right? So that's the zip function you are going to have. So it is going to take like publisher source 1, source 2, and source 3. So if there are like 3 sources, then you should consider seeing 3 lines, right? So it is going to zip all these 3 publisher elements, and then it is going to produce something like this. So likewise, for each and every function here, you will see a marble diagram to understand those functions. So understanding these functions are not going to be easy. It's going to take your own time, sweet time, to understand all these things. And you need to be very good in Lambda expressions. So Java 8 programming model, if you see, there is a new addition called Lambda expressions. You should be very good in that. Then only these syntaxes you will understand. Also, you should be very good in Java generics. So the generic types like this, it will come. So you should understand. What do you mean by this? Question mark extend 0. Question mark super object array. What do you mean by this? You should understand this, right? So you should be very good at Java generics, and you should be very good at Java 8 Lambda expressions. Then only these functions you will be able to understand. If your fundamentals are not good, then you will never understand these things, how it will work, right? Or how I can construct those syntaxes. Any experienced Java developers also feel tough to write this reactive pipeline. Now I'm going to write a pipeline now. So my publisher is numbers flux. So numbers flux, I'm going to call a method here, and using that method, I'm going to add a numerical value. So currently I have an integer value 1. I will add a numerical value called ONE with this particular 1. Or I will add some numerical value for simplicity. I'm going to do. So I'm going to call a map function. And in this particular map function, it's a transformer. And here, if you see, it takes a function as a parameter. The function is again an interface. You should know a Lambda expression, how to write a implementation of this particular function. Function is nothing but it's going to take your numbers, each and every number as an input, and it is going to return whatever type it wants. So I'm going to return something like this. I'm going to return something like this. That's it. So this is only one function. What I'm going to write it in the pipeline. So in the picture, if you see, there are like 4 functions we have described here. Now we have written only one function called map. And now we need to attach a subscriber. So we didn't attach the subscriber till now. We created a flux. We added a kind of say map function, and then we will attach a kind of subscriber now. So let's call a subscriber. And then subscriber takes a consumer, which is going to return the on next, each and every element which is there inside it. So let's write a Lambda expressions for it. Right. So if you are not going to add a subscriber, then your pipeline itself won't get created. Nothing will happen. Definitely you need to add a subscriber. Nothing will happen in your underlying application. The pipeline won't get created. Okay. So now we have added the underlying subscription. Now we have one publisher, a flux publisher, and then there is one intermediary function. We call it as a transformative function that is going to take each and every element which is there in the flux, and each and every element is an integer type. For that integer type, we are appending a string type. Now your output becomes a string. This is the output, right? The output becomes string. That string is what is printed here. I just put str here. That string is what is getting printed in our say subscriber. So let me run this and show. So if you see here, output is nothing but whatever we are printing in the subscriber. So one numeric value appended with numbers. So numbers is the value what we are appending. Similarly, two numeric value appended with it. So the for loop and everything is internally happening because flux is going to loop it through, and for the map function, flux will pass each and every element what it has, and then that each and every element is going to do append with numbers, and the output of the map will become a string now. That string is what is passed on to this particular subscriber, because subscriber, I am invoking on next function now. This particular on next function is just printing the underlying results what we are getting after doing the transformative function of map, and it's going to print the underlying value. So this is what a simple pipeline will look like. Now I'm going to convert or change this pipeline in which I am going to add a method like this. And moving the business logic here to this particular method. Instead of writing lambda expressions here, I'm going to write a method reference. So JDK8 has something called a method reference. You will be putting double colon and you will be able to write this particular method reference. This function has to be a static function because the main is static. So from static, I'm going to call this print thread, and this function has to become a static function. Now I can write more lines of code here, right? I'm going to print the current thread. So thread dot current thread, I'm going to print it here. So when I'm going to print the thread dot current thread, if you see here, the thread name is going to be main, and it's going to have the parent thread name is going to be main, and it's going to have the priority, thread priority as 5, and the current thread which is running this particular pipeline is also main. Everything is being run by main. So what do you mean by that? The entire pipeline now is executed by a main thread. Main thread is nothing but the thread which is starting this particular main function, right? So, but now the advantage of say going with the reactive pipelines is like we want this particular map function to be executed in a separate thread, not with the main thread. So in order to demonstrate that, I'm going to introduce another map function. I'm going to introduce another map function, and this particular map function is going to have say another version of print thread 1. I'm going to write print thread 1 separately. Print thread 1 takes string as a parameter, and then it's not going to do anything. Simply it's going to return the same string. It's not going to do anything, but we will print the thread. So I will put as a identifier. This is the second map, and the first one here we put an identifier as this is the first map. So I wrote two map function now. One is going to call print thread, and this system println will get printed. Another one is going to call a print thread one. So another one is going to call a print thread one, and is going to do some kind of thing like this. So now what we are going to demonstrate is like, we want the second map to be executed in a different thread. When I'm going to run this, everything will run in a same thread. I'm going to extend this particular application so that it's going to run in a different thread. If you see the output, all the things are running in a same main thread. Only one thread is running the entire pipeline now, right? So entire pipeline is now being run by this particular main thread. Now I'm going to change it. In order to change it, now we introduce a concept of schedulers. So there is a function called publish on. So I call that particular publish on. Sorry. All that particular publish on, and it is having a scheduler. So schedulers, and here you will be able to choose a thread pool. So I don't want the main thread to get executed. I want a different thread pool to get executed. So I will create my own thread pool to do this. So I will create a thread pool by myself. So here, executor. Executors dot new fixed thread pool. We put 10. And this particular thread pool, in single line, you can create thread pool. This is JDK 1.5. We have java.util.concurrent API. So using that, you can create your own thread pool. That executor is what I am passing on here. So what I am telling is like, as soon as this part of the underlying pipeline comes, please ask the main thread to go back and let this particular thread pool takes control. Let this particular thread pool takes control. That's what we are telling here. And when I'm going to run this, you will see some weird things coming up. When I'm going to run this, all your first map is running in main thread, right? All your first map is running in your underlying main thread, but see your underlying second map. Second map is not running in main thread, but it is running in an executor thread pool. So pool 1, thread 2, pool 1, thread 2, pool 1, thread 2. So all the 5 elements which is there in the flux, when it is going to execute the second map, that is going to run in a separate thread pool. And in that separate thread pool, there is a problem here actually. In that separate thread pool, one thread has been taken, and that thread name is pool 1, thread 2, pool 1, thread 2, pool 1, thread 2. So all 5 elements, when it's going to run this line, it is being run by a single thread taken from this particular executor, whereas this executor has 10 threads now, right? This is also a problem. This is not a true parallelism, right? This is not true parallelism. I'm just making my main thread to go off, and then I'm asking this particular executor to take control to execute your underlying second map. But how it is executing it? But it is executing with a single thread from this particular executor. This is not true parallelism. What I need to do? I need to do some more work in order to have a true parallelism. If you want true parallelism, what do you mean by true parallelism? So there are 5 elements now in the pipeline, and all the 5 elements is going to be passed on to this particular map. I want each and every element to be executed in a separate thread, right? So currently each and every element in the second map is being executed by a same thread. If you see the thread name, it's going to be the same thread. But I want each and every element to be executed in a separate thread taken from this particular thread pool. This thread pool is going to have 10 threads, right? So we want to do something like that. So in order to do that, what we are going to do, I will switch back to Lambda expression, and what I need to do in order to do that. In order to do that, we need to create child pipelines. So you have a main pipeline now. So if I want to do true parallelism, I need to create child pipelines. All your child pipelines has to be connected back to the main pipeline as well. So if I want to create a child publisher for each and every STR, what I am going to get in the map, I need to create a child publisher, right? So let's create it. So I'm going to create a mono now. Mono is also a publisher, right? So mono from or mono just str. So I'm creating a child publisher now, and then I'm going to switch the thread now, right? So I want to switch the thread. So what I will do is like, I don't want to switch the thread because this executor is already switched outside this particular map, right? So we'll be there in the map. But if you want, you can switch the thread here also. Probably I will do that. So I will put the same thing here as well. Then we'll call a map. In the map, we will call main : print thread 1. And this return goes off now. And we need to use return here. And we need to put a semicolon here. And then instead of flat map, we need to change it to flat map. Map also, there will not be any compilation error. But what is the problem is, if you just call map, then somebody has to, if I just call map, somebody has to call a subscriber here. As I told you before, if I call subscriber, then only the pipeline will get executed. See, here I am creating the pipeline, mono publisher, I am creating it. I am changing the thread to use this particular executor, and I'm calling a map. But who is calling the subscriber? Nobody is calling the subscriber. So somebody has to call the subscriber, and for that reason, we are going to use a flat map operator. So there are a lot of usage of flat map operator. It is going to flatten the structure, what we are going to get back. We might not understand what do you mean by flatten the structure now. So you need to learn these operators. As I told you, there are more than 300 operators available. Map is just one operator, flat map is another operator, publish on is another operator. There are 300 operators like this, and we should learn these operators in the flux and mono type. Now what we are going to do, I will tell you the behavior, how it is going to be. When it's going to enter this particular map, each and every element is a child publisher. Each and every element is converted into a mono. Mono is nothing but a pipeline by itself. And then that mono is going to run in this particular thread pool. And then in that particular thread pool, using each and every thread, this print thread 1 will get executed. When we run now, for each and every element, a new publisher got created, and that each and every publisher will run in its own thread. Let's see. If you see now, look at here, second map, look at here, it is 3, it is 4, it is 5, it is 6, and it is 7, right? Previously, if you saw, only one number came here for everywhere because it is running in one thread from that particular other thread pool. Now it is using multiple threads from that particular thread pool to run. This is the true parallelism. So in a reactive pipeline methodology, if you want true parallelism, what do you mean by true parallelism? Each and every element in the flux has to be executed in a separate thread. Say, for example, each and every element, you want to make a network call. If you are going to make a network call with a single thread, then it's going to be costly. It's going to take time, a lot of time, right? Because it becomes sequential. Only one thread will call the network call, and it will wait until the response is going to come back, and the same thread will call the second element to make a network call, and then the element, the response is going to come back. That's going to be slightly costlier, right? But if I'm going to use a child pipeline like this, now everything runs parallelly. So I'm going to make use of the entire thread pool, and this size I can increase as well, and everything is going to run parallelly, and you will get true parallelism. So that is all what we know, what we need to know about our schedulers, right? I can extend the program by giving you some kind of time, like measuring time, how fast it runs and all those things. Maybe we should not do that because we are running out of time. We need to run a small web flux application and then we will finish the webinar, right? So if you see this final code, if you are not knowing Lambda expressions, this will be difficult to understand. You have to know Lambda expressions very well. So there is a Java 8 course, what we have in GUVi. So if you are interested, you can have a look into that particular Java 8 course. I think currently all the courses are free of cost, right? So that's what I heard from the GUVi folks. So you can look into that particular Java 8 course that is done by me only. And it is done in Tamil language, not in English. It's been done in Tamil language. And we have a very detailed, say, explanation on Lambda expressions and streams. So if it is there open, free of cost for everybody, you can go and look into that. So learn the Java 8 programming model first, right? So then only, that's the basics for writing the reactive pipelines, right? So that's the basics of writing the reactive pipelines. There is something in chat. Okay, fine. So we will take another 15 minutes to complete. So this is the kind of programming model what you will get. So using this pipeline programming model, you can switch threads very easily. So from the main thread, I can go to some other thread, and then I can come back to main thread, and I can do whatever I want. This kind of programming model is now extended to do web application. That's what WebFlex programming model. So Spring has created something called WebFlex programming model. And this is the Spring WebFlex programming model. So their existing Spring MVC has been updated to use reactive types. That's what we call it as a Spring WebFlex programming model. And behind the scenes, it uses Netty server. So it doesn't use Tomcat server. It uses a Netty high performance asynchronous IO library Netty has. So it's using that, and the project Reactor to run the web server. That's what the Spring WebFlex is all about. Let's write a small example for Spring WebFlex. So I will go to my Spring Boot main, and I will write it here itself. I can write it as a separate class, but let me write it here itself. This is a REST controller, and let's write a constructor, and let's start writing a method. So flux of, say, customer, get customer, and this is going to be like a get method. By default, it will be JSON and all those things. So we need a customer object as well, right? So let's create a customer class. I'll quickly create 3 member variables. And a empty constructor. And a typical getter setter method. Let's generate that. A typical getter setter method. Fine. Now let's create a customer. Say let's put a loop and create a customer. Say so we have created a loop, and then let's create a customer. ID, let's put I plus 1 as the value, and then name, just say a sample name. So I'll put John plus I. Then description, just a sample description. I'll just put test. So 5 customers will get created, and we need to create a flux, right? So in order to hold these customers, let's create a list, and from list we will convert it into a flux. A list. and here list dot add. We are done. Right now we need to return the return type now. So here let's go and return. Return list. This work. So return list is just a list, right? So we need to convert it into a flux. So let's convert this into a flux by converting this list into flux. So flux dot from iterable list. This is already there. So this will convert the list into flux, and then we are returning this particular say flux, right? So a typical web flux will look like this. Instead of returning a regular response or a object which will be converted into a JSON, we will be using a publisher type. We will be using a flux type, or we will be using a mono type, and that's where the reactive thing will come into picture. And inside your method implementation, you can start writing reactive pipelines. I didn't write any reactive pipeline here, but an imperative code I wrote using a for loop and all those things. But you can write a reactive pipeline in order to do whatever business logic we want. And finally, you will return a publisher type after you complete your underlying business logic. So this is how a WebFlex programming model is there. There are other features of WebFlex programming model, but we are not going to look into all those things. We just started with a basic hello world kind of. Right now, we'll start our server and quickly go to browser and have a look into. So now Neti will get started. So Neti got started instantly. So Neti is running in the port 8080. So let's go to port 8080 in the browser and then call the localhost 8080 localhost colon 8080 / cus. Let's go and do that. So this has executed, and we got the flux of customer, which is nothing but our 5 objects of customer, has been converted into a JSON as a JSON array, and we got the response as a JSON array. So this is a Spring Boot programming model, and then on top of Spring Boot and on top of Project Reactor, Spring has created something called Spring Web Flux. There are a lot of features of Spring Web Flux. Of course, this is just a start point of the Spring Web Flux, what I have just demonstrated. But before learning Spring Web Flux, all of us should learn about the Lambda programming, Lambda expressions, and we need to have a very deep understanding of Lambda expressions. If you don't have a deep understanding of Lambda expression, then Lambda expressions and method references. If you see double colon here, this we call it as method references. Then none of the source code we will not be able to understand. First, we need to learn that. And after that only, we'll start learning the reactor types. So Spring Reactor and then the pipeline programming model and all those things. And then we need to learn about the Spring Web Flux, Spring Boot 2.x and Spring Web Flux, right? So there are, see, if you are going to create the reactive programming model, then end to end, everything has to be reactive. What do you mean by that? If I'm going to write a log, then that has to be in a reactive way. It has to be a part of the reactive pipeline. If I'm going to make a database call, your database driver has to be a reactive driver. That's very important. Your database also should support reactive request response, right? So only certain DBs will support it, not like RD. Most of the RDBMS don't support it. But this NoSQL DBs like MongoDB and all those guys, they have a good reactive driver, right? So if your database calls are not reactive, then writing a reactive application is of no use, right? So because the wait time, again, your thread is going to be like waiting, right? So if your database calls and your log writing and your call to your another RESTful services, everything has to be reactive. Then only the end-to-end reactive advantages and features you will get. Else, the old problem of your thread waiting and all those things you will get, right? So that's the kind of say understanding what we should have. Now I think I'm done. So this is what I just want to give the basics of the reactor programming model, why we have this kind of asynchronous programming model coming up in the server side, what is the kind of advantage, and then how to write a simple hello world, and then how to switch threads, right? How to get true parallelism in the reactive pipeline, and then what do you mean by this web flux, a simple get start with the underlying Spring web flux. So this is a kind of basic introduction what we need to know about this reactive systems using Spring Reactor. Going forward, most of the organization will use the asynchronous programming model, the reactive programming model in the server side going forward. That has a lot of advantages, right? So that has a lot of advantages on say the performance and then responsiveness and all those things. So a lot of organization will start using it, right? So it's a good thing what to learn now. So Spring Boot 2 and Spring Webflux Project Reactor, right? That is what will be used by a lot of organization going forward. Right? So I'm also building a Spring Boot 2.x video material, and we'll be hosting it in GUVi. And in a 2 weeks period of time, it will be completed. It's a detailed tutorial on Spring Boot 2. It will be in English, not in Tamil, which will be hosting in GUVi as well. So that's the thing what I just want to give in this webinar. If we have any questions, we can start discussing now in the chat. Probably speaking, everybody speaking won't work properly, right? So if you have any questions, you can type it in chat. I will start speaking on it. Okay, so if we are not having any questions, we are done. And thank you, GUVi, for hosting this particular webinar. And thank you very much for hosting this particular webinar. We are done with the session. So I think the host in GUVi wants to talk.
Hi Gajendran, Bala here from GUVi.
Hi Bala.
Hi, thank you so much Gajendran. Thanks for joining us on this short notice. It was actually a pleasure to hear from this topic actually. So we've been talking about this React systems for quite long, but it happens that you were able to help us with the knowledge sharing for this today. Okay, so team, thank you so much for the participants for joining us. So you would have really felt it useful, right? So so Gajendran, he has more than 2 decades of experience on these systems, and he's generous for us to help us on this. So stay tuned for more such sessions, and obviously you can learn from him a lot, okay, in terms of these particular systems or the other Java part. So he's an expert in Java. So as he already mentioned, right? So you can go and check out his Java courses, which are available free right now in GUVi platform as well. Okay. So if you haven't subscribed for those earlier, please do go and join it, and it will be of sure help for you to be to lay the foundation for these courses, for these subjects. Okay. So thank you so much for joining, and thank you, Gajendran. So looking forward to host more sessions in the future.
Yeah, thank you, Bala. Yeah, definitely we can do more sessions. Yeah, thank you.
Okay, guys. So this is a recorded session. Yeah, we'll share it in the YouTube as well. So in case if you feel that this is actually quite useful, please share the link to your friends as well. Okay.
Yeah. Thank you.